This is section 6.4 on rectangles. First of all, the definition for a rectangle is that it is a quadrilateral with 4 right angles. Now, because it is also then a parallelogram, it has all of those same properties. The reason we know it's a parallelogram is that since this has 4 right angles, we know that this top side is parallel to that bottom side by the dual perpendicular converse. Likewise, this segment is parallel to the one on the right for the same reason, so it meets the requirements for the definition of a parallelogram. So it has all those same properties. Diagonals are bisecting each other, opposite sides are congruent, and so forth. But it also has some other properties. One of those has to do with the diagonals, and that's probably the most important one we're going to look at. If I draw in this diagonal as well as the other diagonal, I believe that those are congruent to each other. And then to verify that, I could look at the 2 different triangles that are formed. First of all, there is this pink triangle, and I believe that it's congruent to the one that overlaps with. Once again, because the rectangle is already a parallelogram, I know that the opposite sides are congruent to each other. Through a symmetric, I know that this segment is congruent to itself. And then since this is a right angle in the rectangle and this is a right angle in the rectangle, I can get this pink triangle congruent with that overlapping one, the one that I'm now coloring in yellow. So those triangles are congruent to each other. Then by corresponding parts, that means that those diagonals, which are the hypotenuses of the triangles, must be congruent to each other. So it has all the properties of a parallelogram, as well as not just diagonals that are bisecting each other, but congruent diagonals. Another property that it has, which might seem a little bit more obvious, is that not only do we have 4 right angles, but we know the right angles are congruent to each other, so it is also going to be considered equiangular. Now, some other things that will be true: consecutive sides or consecutive angles are not just supplementary to each other like they are in any parallelogram. Consecutive angles are going to be congruent, and opposite angles would be supplementary. Again, not necessarily true in a parallelogram, but those are some properties that will be true. Some ways that we can prove that a shape is a rectangle. First of all, if we can prove that it's a parallelogram and it has congruent diagonals, that implies it must be a rectangle. So there's one of our ways to prove rectangle. Additionally, if we can prove that it's already a parallelogram and we have consecutive angles that are congruent to each other, that also means we know it must be a rectangle. And a third method, if we can prove parallelogram and even just one right angle, that means they all must be right angles, so it must be a rectangle. So there's really these 3 reasons, as well as the definition, which says if we can get a quadrilateral to have 4 right angles, then it must be a rectangle as well. So 4 different ways we can prove that a shape is a rectangle. 3 of them involve proving parallelogram first, and the other one just have to get a quadrilateral with the 4 right angles. We have 7 problems here where I'm asking you to classify the shape as specifically as you can. I would recommend pausing the video and taking some time to look through these and try to answer them, and play it when you're ready for the answers. As it is, I'm going to go straight through the answers. In this one, we have segment AC is equal to segment BD, which is great. We have diagonals that are equal to each other. However, we never established the fact that this is a parallelogram, so the best name I could give to this one is just quadrilateral. Number 2, I can get parallelogram because we have one pair of opposite sides that are parallel and congruent to each other. It's a parallelogram with 1 right angle, which means they all must be right angles. So this one can be classified as a rectangle. Number 3, both pairs of opposite sides are congruent, so it's at least a parallelogram. And we have consecutive angles that are congruent to each other. So these angles not only are supplementary because of the parallelogram part, but now that I know they're equal to each other as well, they must be 90 degrees. So they're all 90 degrees. So number 3 also is going to be considered a rectangle. Number 4, we have parallel, or we have 2 right angles. That means using the dual perpendicular converse, I can say that this segment is in fact going to be parallel to that segment. So that allows me to say, all right, this must be a parallelogram. And since it's a parallelogram with a right angle, that means it is going to be a rectangle. In a plane, if 2 segments, these two on the outside, are perpendicular to the same line like this bottom one, then those two lines must be parallel, and that's how we got to the parallel part. Number 5, both sets of opposite angles are congruent to each other. However, we don't know if they're right angles or not, so the best name we can give to this one is parallelogram. Number 6, we have two pairs of sides that are perpendicular to the bottom, which means that these must be parallel. However, unlike the last one, we don't have any lengths. We don't know if this segment on the left is equal to the one on the right, because maybe they are, maybe they're not. Maybe this other one on the left is up a little bit higher. In that case, we get the shape that looks something kind of like this, which is definitely not a parallelogram of any sort. So the best name we can get for this one, once again, is just quadrilateral. We can never establish that it was a parallelogram. Number 7, because those diagonals are bisecting each other, it's a parallelogram. Using a segment addition postulate, we could eventually get that these diagonals are congruent to each other. So we can say more than parallelogram, we can even say that it is a rectangle. Next, we have our first proof, trying to prove something is a rectangle. Once again, I'd pause the video, copy this down, and then you can either try it on your own or follow along with me as I go through it. I'll be writing this one as a paragraph proof. So first of all, we have the given. YF is perpendicular to AF. LA is also perpendicular to AF. So we have, in a plane, we have two segments that are both perpendicular to the same segment, which means that those two segments must be parallel to each other. Specifically then, using perpendicular transversal converse, we can say segment LA is parallel to segment YF. Those markings up there now to show me that I have parallel. LA is congruent to YF. We were given that as well. So as I look at this now, I can say ALYF is a parallelogram since one pair of sides that are parallel and congruent imply parallelogram. So we have parallelogram. Now I'm trying to get to the rectangle stage. And I'll go back to this first part of the given. Since YF is perpendicular to AF, I'm just going to focus on that. And I can say, using the definition of perpendicular, we know angle F is a right angle. And I could have said angle A is a right angle, and I could even say that both of them are a right angle, but all that's significant is that we have at least one right angle. Because now what we have is a parallelogram that also has a right angle. So in conclusion, since ALYF is a parallelogram with a right angle, we know ALYF is a rectangle. End of proof. Next, we have another proof. We're given a parallelogram for the entire shape. We're given that this inner shape here is a rectangle, and we're trying to prove the two triangles on the outside congruent to each other. Start with the given. Since the entire shape is a parallelogram, we can say that this segment is congruent to this one. So since parallelogram implies both pairs of opposite sides are congruent, we know segment KY is congruent to segment AC. And we could say some more things. I'm just going to stay with that one. Next, YLCH is a rectangle. Since YLCH is a rectangle, it is also a parallelogram. And that is just a fact that we know. That's one of the luxuries we have in a paragraph proof is we can state facts like this. Next, since it's a parallelogram, since parallelogram implies both pairs of opposite sides are congruent, we can say that segment YH is congruent to segment CL. So we have those two segments congruent to each other. And as we're looking at the triangles we're trying to prove congruent to each other, we have two pairs of sides. We're going to go further with that using the definition of rectangle and definition of right angle. We know YH is perpendicular to KC and LC is perpendicular to AY. So we have perpendicular. I'm going to put some angle numbers in here using the definition of perpendicular. We know angle 1 and angle 2 are right angles. We don't have to prove them congruent. All that's important is that we do have some right triangles. And now I don't have side-side angle, but I do have hypotenuse leg. So applying HL, we can conclude triangle CAL is congruent to triangle YKH. Last problem we'll look at is a coordinate problem. I have ABCD, and I want to classify it as specifically as possible. So point A, point B, point C, and point D. I'm just putting them in roughly the right location. Connect them together, and we have this shape. And I want to classify that as specifically as possible. There's a lot of ways we can do this when I'm going to stick with the slopes. Calculate the slope of AB. That's going to be 4/8. Calculate the slope of DC. We can check really quickly to see if they're parallel to each other. That's also going to be 4/8. So what I know about that is those two segments are parallel to each other. Next, I'll check segment AD. The slope of segment AD is going to be -4/2. Calculate the slope of segment BC. That's going to be equal to -4/2. And likewise, those two segments are parallel to each other also. So at this point, because we have two pair of sides that are parallel, we know it's a parallelogram by the definition of parallelogram. More than that, we're trying to check to see if we have a rectangle. 4/8, we haven't simplified these before, but 4/8 simplifies down to 1/2. -4/2 simplifies down to -2. So when we compare those two numbers with each other, not only do we have two pairs of sides that are parallel, we have slopes of 1/2 and -2, which tells us perpendicular. So we have right angles, we have parallelogram. The most specific name for this shape then would be rectangle.